Hello, everyone. My name is Zhou Liguan. I'm from the Chinese University of Hong Kong, Shenzhen, and I'm also working at Shenzhen Institute of Artificial Intelligence and Robotics for Society. So today I'm going to present a paper, namely long-range hand gesture recognition via attention-based SSD network. The presentation mainly includes 6 aspects. First, I'm gonna introduce the motivation of this paper, then the related works will be introduced. Later on, the methodology and the experimental results will be presented. Lastly, I will present an application demo and draw the conclusion of this paper. So from these 3 figures, we can tell there are person. First one, a person sitting in front of a television, trying to use his hand to control the vehicle in the game. In the second figure, there's a doctor who is trying to use his hand to interact with an organ in the computer, where he used his hand gesture to interact with the organs inside the computer. For the last one, there's a man driving his vehicle and using his right hand to trying to control the panel of the vehicle. So from these 3 figures, we can tell the hand gesture recognition is only limited at a close range, or mainly 1 meters. So when it comes to long distance gesture recognition, for example, over 5 meters system, the recognition accuracy would be dramatically decreased compared with the close distance. So my question is, can we really develop a long-range hand gesture recognition system that can recognize the hand gestures more than 5 meters away from the mobile agents or a camera, so that we can enable the long-range hand gesture recognition with UAV, so that we can use a UAV to interact with a human at a longer and a safer distance. There are related work using his hand, or you can say arm posture, to interact with the robot. The farthest detection distance can reach 5 meters, but this is not enough because we can use a very large like arm posture, but we cannot use only a small area like hand gesture to interact with the robots. So for the second one, we can use the hand gesture to interact with the simulation, the car in simulation. The interaction distance is mainly, in this figure, is only like 20 centimeters, which is very limited. All of these two cannot be extended to long-range hand gesture recognition. And there are 2 papers from ICRA2021. Left one is several persons sitting in front of the mobile robots, and the interaction range is between 0.5 meter to 2 meters, which are also limited. And for the second one, a person sitting in front of a robot, and you can tell there are 8 persons with different hand gestures, but the same part is all of these hand gestures are only in 1 meter, which is relatively limited. So can we really prolong the hand gesture? In this one, we can tell there's a person sitting in front of a dual robots and trying to use his hand to deliver the control command to collaborate with dual robot. But the point is, the interaction distance is still limited. This is from ICRA 18, which is recently published. All of this work with limited distance. And for this one, I want to introduce the reason why we are using SSD as the backbone. From these two papers, the conclusion is the SSD can recognize small objects performs better on the small object recognition, while YOLO performs worse. So that's the reason why we are using the SSD as our backbone. And the next is we are gonna introduce the original data set. It's namely American Sign Language, which use gesture 1 to gesture 10, 10 just standing for the number 1 to number 10. But this is collecting at a close distance. You can tell there are women sitting in front of the desk, and there will be a camera capturing their hand gestures. But the same part is the distance between camera and the hand gesture is like only within the 0.5 meter, which is relatively limited. So we really want to extend to long range hand gesture recognition by collecting a long range hand gesture data set with 8 different human people perform 10 different hand gestures. And the data set is open source at this website. You can take a look at. And this is 10 gestures, the same as the previous data set. But the difference is that we are collecting the hand gestures at various range. For example, there are 3 data sets, namely text mix short, text mix X, text mix long, where short means the short range and mix X means multiple range, and long means specifically for the long range hand gestures. You can tell from here, the hand gestures are mainly collected more than 5 meters from the camera. And this is the detailed information of this data set. We have 2 data sets. Both of these data sets are from this long range hand gesture data set. From the short one, from the multiple range, we have chain mix range and test mix range. And we also extract 2 data sets from this test mix range, which is text mix short range and text mix long range. And short range, you can see the hand area of hand gesture distribution in the right side. This is a test mix range short data set. The hand is collecting at a short range, so the hand area is mainly around the 5,000, while for the text mix long range, which the hand gesture are collecting a long range, where the hand gesture, the area of hand gesture mainly between 100 to 500. And meanwhile, we are taking a tiny hand data set and a medium hand data set from this data set, long range hand gesture data set, where tiny hand gesture are standing for the hand gestures with areas less than 1,000, while median hand gestures has area between 1,000 to 4,000. Standing for the hand gesture are collecting between 2 to 4 meters, while for this tiny hand gesture data set, where the hand gesture are mainly collecting at more than 5 meters. So this is the data set collected by ICIP, and previously there's one method using cascaded SSD, with 2 SSD. One is for hand shoulder area detection, where they believe the hand gesture mainly resides in the hand shoulder area, while the second SSD is used for the hand gesture recognition, where it's kind of redundant because there are 2 SSD for the detection of the small hand gestures. Can we reduce one SSD and to make our algorithm more efficient? So therefore, there's an attention-based SSD network being proposed in our paper. We are adding an attention-only channel block attention module that we attach this attention to our backbone from position 0 to position 5 to refine our intermediate feature map. And this is the CBN module, and you can tell the input feature is being refined in channel dimension. And afterwards, the refined feature will be sent to the spatial attention module, and the feature will be refined spatially. So the final feature map has a better performance compared with the previously input feature. And this is qualitative results, and you can tell that the CBA and SSD outperforms joint SSD and SSD, where SSD and joint SSD fails to recognize hand gestures that are collected at 5 meters long from the camera. And this there, the blue box showing is the ground truth, while green box are the predict result by the corresponding method. This is a qualitative result, and you can tell the CBN-based SSD is much higher than SSD, while SSD fails to recognize hand gestures at long range and mix multiple range, while also the joint SSD performs worse than the CBN SSD. And joint SSD has two SSDs, where their parameters are twice much as the CBN SSD. So therefore, this one outperforms the previous method and has less parameters. And also, we test our method on median hand dataset, which are collecting between 2 to 4 meters, while also we test our dataset only on a tiny hand dataset, which the most hand gestures are collecting more than 5 meters from the camera. And you can tell the performance of our CBN-based SSD are greatly enhanced compared with the SSD method. And this is comparison with state-of-the-art systems. And you can tell our system can recognize the hand gestures that are up to 7 meters from the camera. This and without sacrificing the accuracy and the mean average precision, and without sacrificing the speed. And we can only use the RGB information. So this is one application we developed for showcasing our system performance. So we can practice the American Sign language by there's a person using different sign language, and this is apple eating game. Person can perform different hand gestures to eat this various apples, and can really practice their hand gesture, side gesture. So the conclusion is we release a dataset, namely LRGSG dataset, which features small and hand gesture collected at long range by a lightweight USB camera mounted on robot, and enable interaction between human and robots at multiple ranges and long range. And also, to solve this problem, we incorporate an attention mechanism into SSD, and notably outperform state-of-the-art method and recognize hand gestures up to 10 meters. 7 meters. So thank you for attendance.